So today we're going again through our basic overview of our quadratic functions. We're going to get into a few more details about the quadratics that we didn't talk about yet. So first thing we have to remember is the standard form of a quadratic, which would be the form ax squared plus bx plus c. And then I have the little note there, a, b, and c all represent numbers of some kind. They're always different numbers. And the main thing is that your a does not equal a 0, because if your a equaled a 0, would we even have that x squared term there? No, because if a was 0, x squared wouldn't be there, and then it's no longer a quadratic. So a has to be some kind of number other than 0. But the main thing with our standard form, as we talked about before, is your largest exponent, and then your next largest, and then your constant comes at the end where it has no variable. So a new thing would be our parent function. For our quadratics, our parent function would be f of x equals x squared. This is a parent function because it is the most basic form of the function. So what happens from there is you've got your parent function, your x squared, and then what they can do is they can take that x squared and they can move it all around the graph. They can move it up, they can move it down, they can move it left, they can move it right, they can flip it over an axis and reflect it. They can make it wider, they can make it narrower, but this is the starting point. This is your parent function, your x squared. So the graph of a quadratic is called a parabola. It's a U-shaped curve. We have parabolas all over the place. Like if you think about if a basketball player is shooting the ball into the hoop, the ball goes up and then it curves back down. It makes a parabolic shape. So when it comes to graphing our quadratic functions, some things you need to know. You always need to include a table of values. If you do not copy that down, you're going to lose points because your table is your work shown. In your table, you always need to have at least 7 points. Now to get your 7 points, you need to look for a pattern in your y values. And I'm going to show you through examples what I'm talking about when I say you want to look for a pattern. Oh, forgot my N, pattern. So sometimes the interval for your domain is given to you. Not often, but it does happen every once in a while. When that is given to you, it would look like this. So that is an example of your domain being given to you. It would say -2 is less than or equal to x, which is less than or equal to 4. So what that means is when you make your table, it's going from -2 to 4. So you would do -2, -1, 0, 1, 2, 3, 4, and you would use your calculator to help you figure out your other side there. So that's telling you what to do in your x values. The other thing is if they give you your domain, you do not put any arrows on your graph. So right here, if domain is given, do not include arrows at the end. Because what they're saying is they only want to look at that graph between those 2 points. They only want to look at it from -2 to 4. They don't want any other part of the graph. So that's why we don't put arrows on it, because we're only looking at that little part of it. All right, so then some important parts of our parabolas. We'll actually go through those as we have our picture of our graph on there. So let's graph this first. So in your calculator, I want you to plug into your y equals the x squared plus x minus 6. So right there under our y equals, again, you should have x squared plus x minus 6 plugged in there, because that's what we're graphing right now. So let's take a look at our table. So here's our table. Now when I talk about finding a pattern in your y-axis, we kind of have one already started here. Your zeros are repeated. Your -4s are repeated and your -6s are repeated. This is the kind of pattern that we're looking for to have in our calculator, where your numbers are constantly repeated just like that. Now normally, you would have one right here in the middle. Now this graph doesn't have it because this graph is a special graph. But most of your graphs are going to have a middle point right in here that this one's currently missing. Well, let's copy this down. So we're going to go from -3 to 3 in our x's. So I'm going to make a table x, f of x. So we got 0, -4, -6. And then 6. So once you have those 7 points, go ahead and graph those on your graph over to the right there. But do not connect them just yet. Just plot your 7 points for right now. Tanner, we're not playing with the calculator right now. So now what I want to take a look at for a second, if we go back to our calculator, push just the graph button. Let's take a look at the graph. So here's our -3, 0, our -2, 4, our -1, 6. The graph, it's not showing it very well here, but it kind of dips down a little bit between our -6s. So when we draw this, we don't need a ruler because this is a curve. And you want to kind of dip it down just a little bit and then go back up. And then we're going to continue with some arrows because this graph is going to keep going. And then, of course, label it with the equation. All right, so now we're going to go through these key words up here. First one, roots and zeros. They use those two words interchangeably. They mean the same thing. Your roots and your zeros are your x-intercept. So it's where your graph touches or crosses your x-axis. So I have a root here. I'm going to label that as R1. And I have a root here. I'm going to label that as R2. So when we write our roots, we always have to say x equals and whatever the number is. So right here, my first root would be at x equals -3. My second root is at x equals what? +2. So that's how we would write our roots. X equals -3, x equals +2. Our axis of symmetry, which a lot of times they do shorten down to be just the letters AOS. That stands for an imaginary line that goes right through the middle of your parabola that breaks it directly in half. So for this one, our axis of symmetry would go through at a half point. We always draw it in with a dashed line. So for this one, our axis of symmetry would be the equation x equals -0.5. Because it's the x value when it goes through the middle of your parabola, and it goes through at -0.5. Our our vertex is also known as your turning point of your parabola. That's when the graph changes direction. So our vertex is right down here for this one. On this graph, our vertex is a minimum. And you write it as an actual point. So the x value would be negative 0.5. It's always the same as whatever your axis of symmetry value is. And the y value is approximately negative 6.25. When it's decimals like that, you're going to approximate, but it's not always going to be decimals. And then our last question we have to get used to, they're going to ask us a lot, is your average rate of change, which is another way of them asking you to find the slope. They give you two x values. They want you to find the slope of a line if you connected those two x values. So let's try, let's see here. Negative 3 to 2. That is one way that they could write it. They would ask you to find the average rate of change, and they would give you this interval. So what you have to remember is those are your x values. Whenever they ask you to find the average rate of change, they're always going to give you the two x values that they want you to find it between. So what we do is we use our table to help us, and we find the full point. So when x is negative 3, we would have the point negative 3, 0. When x is positive 2, we would have the point 2, 0. So you use your table to create the full point. They give you just the x values. You need the y values that go with them. And now this formula looks kind of confusing, but if I replace those f's with y's, what formula is it? It's your slope formula. That's all it is. Average rate of change is just your slope. So once I take my 2 points, I'm going to do y minus y over x minus x. So 0 minus 0 gives us 0. 2 minus a negative 3 means we're actually adding, so we're doing minus a negative. So it would be a 5, but 0 over 5 is just what? 0. So that one is just a 0 for our average rate of change. So all you got to do is find the 2 points and do your slope formula. That's all average rate of change is. All right, let's take a look at our example on the back here. So this time they tell us to graph f of x. This is still a quadratic. It's just written in a different form, which we'll talk about that form in a couple of days. But still a quadratic equation there. This time they gave us the domain. They gave us the x values to use. So when I start my table, I'm not even going to type it into my calculator yet. I'm just going to fill in my x values. They told me to go from negative 1 to 5. So what I want you to do right now, in your calculator, under your y equals, clear out what we had last time, type in that quadratic function, and finish your table up. So let's take a look at this. There's so much good information within just between the table and the graph here. So first off, this table is much better at seeing your pattern because your top and your bottom number are the same, and then those next two are the same, and then those next two are the same. And as I was talking about before, you have a definitive middle point in that table. So this table is like ideal. This is the kind of table you want to look for every single time. So let's talk first about our roots and our zeros. How many roots do we have? 2. Here's my first one. I'm going to label it as R1. There's my second one. I'm going to label it as R2. What are my x values at those 2 points in time? 0 and 4. So x equals 0, x equals 4. Those are my 2 roots. Our axis of symmetry, it's a lot easier to see it this time. Again, it's that imaginary line that goes through the middle of your parabola. which this time lines up very nicely on a whole number. We always show our axis of symmetry as a dotted line, and we label it as AOS. So what is the x value at our axis of symmetry? X equals, so we write that equation, x equals 2. Okay. All right, so our axis of symmetry, x equals 2, goes right through the middle. We always label it as a dotted line. So then our next thing would be our vertex. Again, your vertex is a point. Your axis of symmetry always goes through your vertex. So that's how you know you found the right spot. For this one, our vertex is a maximum. And it would be the point 24. Now, the really cool connection I want to make between your table and your graph is this middle spot of your table is your what? Vertex. That's how you know you found the right one. Your vertex is always that middle spot on your table. So it wasn't on our last table because it was a decimal, but when it's a whole number, it's always in the middle. And then over here, if you isolate just this number, that's your axis of symmetry. So you can get those two things right out of the middle of your table. Oh, we'll circle that. Forgot that's a maximum. I forgot I made that a separate question.
If it doesn't have a separate question like that, do you write it with a vertex?
No, I'm just writing it right now to get you to see the difference between a maximum and a minimum. All right, so now we have a question based off of our graph. We have find the value of f of negative 1. These questions are always difficult because it's tough for you to understand what they're actually asking you for here. So what letter do we normally have in those parentheses? An x. So this is really asking you, when x is negative 1, where is your graph? So if we go to our graph, or you could go to your table, go to where x is negative 1, where's the graph located? So f of negative 1 equals negative 5. It's really not that bad. Again, you just have to remember that they're just asking you, at that x value, where's your graph? So now here, they're asking us for average rate of change. They are using a different kind of notation, but it's just like what I was talking about on the first page. They're giving you your x values. So we got to make our 2 points. So when x is negative 1, what's our y value? And when x is 2, our y is a 4. So those are our 2 points, negative 1, negative 5, and then 2, 4. And now we can do our slope formula. Y minus y over x minus x. So again, when we're subtracting a negative, what happens? Turn to positive. So 4 plus 5 is 9. 2 plus 1 gives us 3. And then 9 divided by 3 gives us 3. All right, so what I want you to do right now is I want you to try to graph this one on your own. See if you can find your table. And then see which of these questions you can answer on your own. We'll go over them in a couple minutes. All right, let's take a look, see how you guys did so far. So that's what your graph should look like. Our two roots are at x equals negative 2 and then x equals 4. Make sure you read your directions underneath there. You need to have labeled them with R1 and R2. Our axis of symmetry was at x equals 1. And again, if you read your directions, you should have your dashed line drawn on your graph and label the equation with your x equals 1. And then our vertex, which you were told to label with the letter V, should have been at 1, negative 9. And that vertex was a minimum this time. Now notice, my graph here has arrows. If yours does not, you will lose points for it. They did not give you your domain to use this time, so you have to include your arrows on there. And as always, you got to make sure you include your label. So then down here they want you to do your average rate of change again. So they want you to go from where x is -1 to where x is +2. So our 2 points would be -1, -5, and then to -8. And then we do our slope formula. So -8 minus a -5 over 2 minus a -1. So that becomes -3 over 3, which is -1. So yeah, they gave you the same x values this time as we did in the last problem, -1 to +2, but your average rate of change is different because it's a different quadratic function, so it's always going to change.